Product disclaimer. The Terahertz blower is not a medical device, and the manufacturer does not provide medical advice. Users understand that the device is not intended for medical or diagnostic purposes. Its use should not replace reliance on medical treatment or advice from a qualified healthcare provider. A true leader knows the way, goes the way, and shows the way. Welcome to Knowing Your Business series.
All right. Good more learnings, everyone. Welcome to Pride Philippines Knowing Your Business series. I'm Rudolph Cruz, your presenter for tonight's fourth episode, which is our topic discussion is about terahertz. Right? I believe everybody is excited because this is the namesake and flagship of our devices. Right? So let me run you through the scope of our discussion for tonight so that you can manage your expectations since the topic is very, very broad and we only have 1 hour or less to do this discussion, right? So the scope, the first part will be the introduction, right? And then you're going to discuss the frequency, the measurement, illustration, and the EMF. And the second part is the main discussion about terahertz. This will include the general information like properties, its sources, characteristics, applications, benefits, and the future application. And at the end of the discussion, you will now understand frequency related to the quote of Albert Einstein that the future of medicine is frequency. Also, you will have the basic and technical know-how about the specifics and the potential of terahertz. I'm not sure if I'm gonna burst your Bible because I'm not gonna discuss specifically terahertz in our iTeraCare devices. That's gonna be the next level of discussion in the coming series. But rest assured, there will be learning. I believe everybody is now ready. Tama ba? So we are all privileged people of Pride International. So let me start with the introduction about frequency because it will be hard to understand terahertz if you will not understand frequency because terahertz is a kind of frequency. All right, let's get started. Frequency is the rate at which something is repeated over a particular period of time. So the thing that is being repeated here is the cycle. Can you look at the illustration here? So the cycle will start from 0. Can you see the cursor out there? The cycle will start from the 0 degrees there, going up above the 90 degrees. Nasusundan nyo ba? Then going back down to the reference axis at 180 degrees. Then going down at 270 degrees. Then going up back to the reference axis at 360 degrees. That completes one cycle. And the rate of that one cycle over a particular period of time is called frequency. So now you know what frequency is. So when you say rate, there is a unit of measurement, right? And the unit of measurement of frequency is hertz. Can you say it? Hertz. Okay, actually it's not plural. Okay, it's not S, it's Z, right? Because if you're going to take away the Z, it's gonna be hurt. It has a different meaning. It's hurt. Okay. but it's hertz, all right? It's Z. So with abbreviation HZ. So be familiar with that. Hertz is the unit of measurement of frequency, okay? And the abbreviation is HZ, capital H and small c, all right? And the period of time is 1 second. So as you can see here, you completed one cycle from 0 all the way to 360. That completes the one cycle in 1 second. And that what you call 1 hertz, right? Can you say 1 hertz, right? So again, the one complete cycle in 1 second is hertz. So there is a equation here. Hertz is equal to cycle over second. It's simply how many cycle in 1 second. That will be the hertz, right? So I'm going to show you some illustration for you to know better, all right? So given the familiar illustration found in our presentation materials, are you familiar with that, right? In one of our slides. So I want you to make use of your imagination, right? So this man will hit the metal to create vibration, right? So the vibration that he will be created will form waves, right? Can you say waves? U waves, right? And the measurement of that wave is frequency, all right? So as you can see there in the example number 1, right? The wave completed one cycle in 1 second and it produces 1 hertz, right? Yan yung example number 1 there in the upper right. And then on the example number 2, in the lower right corner, the wave created 5 cycles. Kumbaga, medyo mas malakas yung vibration na ginawa. So, created 5 cycles. Again, the time is fixed in 1 second. So, the wave created 5 cycles in 1 second. So, it produces 5 hertz. So, that's how you read hertz. All right? So it's getting many already from 1, naging 5. And this time, the example is 20 cycles in 1 second. So anong tawag doon? How many hertz is that? So that's 20 hertz. So that's simple as it was. All right? 20 cycles in 1 second equals to 20 hertz. So as you can see here now, the numerous kind of cycles. How about 1 cycles? So that's 1,000 hertz or 1 kilohertz. So the abbreviation will be capital K, capital H, and small z. How about 1 million cycles? So that is 1 million hertz or simply 1 megahertz, right? How about 1 billion cycles in 1 second? So that will be 1 billion hertz or simply 1 gigahertz. So makikita nyo yung abbreviation dyan sa gilid. So it will be better if you can at least memorize those abbreviations so that when you come along reading research about terahertz, you will know what it means. All right? So here it is now. How about 1 trillion cycles? So that will be 1 trillion hertz or simply THZ 1 trillion hertz. Wow! So now you know how powerful terahertz is by merely the basic measurement. It's about 1 trillion cycles to make it 1 trillion hertz. All right? So I believe you're getting it, right? So here now, let me guide you to the simple spectrum. So from left to right, the frequency is increasing. So it will start from the left, which is the very low frequency, all the way up, going right to the ultra high frequency. So meaning to say, Habang nagpupunta siya sa right, mas lalong lumalaki ang sukat ng frequency. Okay? So the explanation I have discussed is just for a simple kind of wave. Kumbaga for beginners. Okay? So please take a look at the figure at the upper left. Okay? Dito sa upper left. Right? So it just comprised of only two axes, which is the X and the Y axis. Okay? Are you going back to your high school days? Right. So X and Y axis. The Y axis represents the cycle, yung cycle na pinag-uusapan natin kanina. And the X axis represents the time, which is 1 second, right? So we can say it's a two-dimensional kinds of waves. All right. So right now, I'm going to introduce you to the three-dimensional waves, which is the EMF or the electromagnetic frequency. So as you can see there now in the illustration, the axes now are three. What are those? The X, Y, and the Z axis. So Y axis represents time and Y represents magnetic field. Oh, there's already a different component here. And the Z axis represents electric field. So that's why it's called electromagnetic field. All right. So take note that EMF waves are radiation waves because of its composition, electric and magnetic waves. I'm sure there will be question about this later on. All right. So I will now show you the complete electromagnetic wave spectrum. All right. So here again, as you can notice, there are the constant number 10 numbers here. And the superscript, the number on top of it, increasing from left to right. All right. Up to the extent of 10 to the 28 superscript, meaning to say that's the number of zeros. Okay. And can you see where is terahertz? Where is terahertz? Is it written there? No, not yet. Because terahertz is not really the part of uh, the standard spectrum because it is just recently discovered around 2 decades ago, right? That's why in the initial and basic standard, it is not yet there. But through our measurement that we have mentioned a while ago, it is how many zero? It is 1 trillion, right? So how many zero is that? So that's 12. So where is it here? So it's 10 to the 12. Okay? It is there. It is between the microwave and the infrared. Yeah, it is in between. So as you can notice on the left, those are just radio waves or electric waves, right? You can see there's a transmission line, and then there is computers, and then there in the microwaves, there are cell phones, and some here is also the microwave oven, and then the infrared, okay, the laser. And then after that, there are waves that are visible to the human eyes. So, ito yung sukat niya from 10 to the 14 to the 10 to the 16. Those waves are visible. Okay? And then after that, it will start those ultra high frequency. Those are really dangerous waves, right? But all of this in the spectrum is, you can safely say it is electromagnetic radiation. So starting from the left all the way down to the right, it is EMF radiation. And as you can notice there down, there is thing as non-ionizing radiation. Okay, so this is very important in our business because most of the time we are hearing non-ionizing, right? And there's, of course, ionizing radiation. We will later on discuss about that word. All right, so there's a question. Who discovered frequency? Anyone? So it was discovered by Heinrich Rudolf Hertz. So maybe it's just incidental. Diba? That's how you know why I'm the one presenting this right now. All right. So it was first predicted by James Clerk Maxwell in his electromagnetic theory way back, right? But it was Heinrich Rudolf Hertz, a German physicist, who first conclusively proved the existence of the electromagnetic waves. That's why the discovery was named after him. It's Hertz. His family name is Hertz, all right? So he is tagged as the father of frequency. All right. So we'll now proceed to our main discussion, which is terahertz. So at least now you know when you see those numbers, you know how that's meant. Okay. So 1, 3, 6, 9, 12. There are 12 zeros. So that means trillion. So 1 trillion cycle equivalent to 1 trillion hertz or 1 terahertz or simply 1 THz. All right. So that is the abbreviation of the unit THz. Right. So what are the properties of terahertz? Terahertz refers to the electromagnetic waves as discussed a while ago, with frequencies ranging from approximately from zero point 0.1 to 10 terahertz. All right. So those are the numbers that we have seen in the spectrum. So it occupies the electromagnetic spectrum between the microwave and the infrared light. So as you can see here, the example of different waves, the radio waves, the microwaves, right? And then the terahertz is in between infrared. And then after that will be the visible lights and then the ultra high EMFs, which is very dangerous to human, ultraviolet, and the X-rays. All right. So what are the possible sources of these terahertz? All right. So first is what we call the quantum cascade lasers. These are semiconductor lasers specifically designed to emit terahertz. Okay, so another example is what we call terahertz quantum cascade lasers or TQCL. It has high output powers and it has a broad tunability across the terahertz spectrum. Another sources is what we call the photoconductive antenna. It is widely used for generating terahertz radiation via ultra-fast optical excitation of semiconductor materials. Another source of terahertz is what we call the terahertz time domain spectroscopy. Right? It is utilized ultra-fast lasers and electro-optic crystals to generate and detect terahertz pulses. All right, so those are the different sources of terahertz. Please observe that those sources are huge. This is not micro, right? Those are really equipment, big equipment. So now you know why Mr. Soma called as privilege because of the invention of Yang Wenjun of generating a source of terahertz na very small and very portable compared to these traditional and conventional sources of terahertz. We will now proceed to the characteristic of terahertz. So as we can see there, non-ionizing. That is the first and one of the major factor or characteristic of terahertz, non-ionizing. Can you say it? Non-ionizing. So in technical term, yung medyo malalim na explanation, terahertz energy does not remove electrons from atoms or molecules. It's gonna be a little bit nosebleed, the explanation, right? So you can review your chemistry, okay? So making it safer for biological tissue, or simply saying that unlike X-ray terahertz, which is yun yung mga high frequency and dangerous EMFs, terahertz waves are non-ionizing. So simply, they don't damage living tissue. Okay, they don't or affect or they don't affect molecules, the composition of the atoms. That's why they are not damaging any human tissue. So this makes them suitable for applications involving human subjects such as security scanners, medical imaging, and potential future medical application where safety is always a concern. So makikita nyo dyan sa picture, the Terahertz body scanner. All right, it can also detect that kind of camera that you are seeing there. All right. So another characteristic is penetration depth, right? So terahertz can penetrate tissues like skin, muscles, and teeth only to a limited depth. So now, is it now making it confusing? So I thought it is penetrating 20 to 30 centimeter. Yes, it is. But by terahertz alone, it cannot penetrate to that level. But thankful because again, if you can remember, we have 3-in-1 core technology. We have quantum. And together with quantum, wrap it into one technology, the terahertz can now penetrate up to 20 to 30 centimeter. All right. But without quantum, but by simply terahertz, it will just penetrate to a particular level in our skin, right? There is epidermis, there is dermis level, all right? So only in a limited depth. Those are the conventional terahertz without the combination of quantum, okay? So that is clear. So we'll now go to the different applications of terahertz. So as you can see here in the illustration or this figure, there's a lot, okay? So I'm going to discuss few of this one by one, right? So first application will be on the spectroscopic application, right? Terahertz is commonly used in spectroscopic techniques due to its ability to probe molecular vibrations and rotation. And what is spectroscopy? This is the study of the absorption and emission of light and other radiation by matter. All right? So, malaki ang contribution ng terahertz when it comes to the application in spectroscopic, right? Because this makes it possible or very valuable in the field of chemistry, biology, medicine, and material science for analyzing the composition and structure of material. So as you can see there in the figure, TSZ, meaning to say terahertz source. And then there is the sensor, the terahertz, and then the terahertz image. So it is being used now. So by the way, this application is what we call the commercial or the industrial application of terahertz. So another industrial application is about security imaging. Alright, terahertz imaging allows for the visualization of objects and materials that are not easily seen without other imaging modalities. Meaning to say, may nagagawang klase ng imaging ang terahertz na hindi kaya ng ibang klase ng modalities. So yan yung advantage, kumbaga ibang level ang kaya ng terahertz when it comes to imaging. Alright, because it can reveal hidden features. It can detect weapons and explosive concealed beneath clothing. So yan yung makikita nyo dyan sa picture. Alright, through the thermal scanning, meron palang bomb tied around the waist or there is a weapon there in the waist. Alright, and there's different objects hidden beneath the clothing. So it can screen for dangerous substances at checkpoints, screen dangerous drugs at checkpoints, identify hidden compartments in luggage or packages, and so much more. So again, it is used in security imaging. And this time around, it is also applied in medical imaging, right? So terahertz can potentially image hidden fractures, soft tissue damage, and internal bleeding without the use of x-rays. Remember, x-rays are very, very dangerous to our health. We can only have once or maximum of twice x-rays in every year, right? So in replacement for imaging is the terahertz, all right? Because terahertz waves can potentially image those hidden fractures. All right, so terahertz also shows promise in medical imaging for applications such as detecting skin cancer, imaging teeth and bone, and monitoring wound healing. All right, so another application is in the biomedical field. All right, so number one here is the cancer detection and diagnosis. All right, so terahertz can potentially identify cancerous tumors based on their unique properties, allowing for earlier and more accurate diagnosis. All right, so terahertz may differentiate between cancerous or benign. Terahertz technology holds the promise for non-invasive monitoring of blood flow, hydration levels, and cellular activity. Again, there is the word non-invasive, meaning to say it is not affecting or it is not damaging our tissue. All right, so another application in the biomedical is what we call there in the breast cancer sample, terahertz pulses are being used, right, through the nonlinear optical crystals. All right, so that is the in the breast sample. All right, so here in this write-up, there are scientific data on terahertz and human health that proves that terahertz is being used in the treatment of diseases including various cancers, including the treatment of angina. This is a kind of cardiovascular disease. As you can see here, there's a lot of reviews, mga medical researches and development, right? And another application will be in the biomedical, in the field of neuroscience, right? As you can see here, right? Terahertz waves can affect the nervous system by regulating gene and protein expression. Terahertz waves were used to stimulate the byway acupuncture point. Yan, that is a point there on top of our head, right? So this is a acupuncture point on top of the head, which is one of the most critical areas for regulating neurovascular activity. All right? And then another thing na application niya is in the neuroscience. Terahertz irradiation improves cognitive impairments and attenuates Alzheimer's neuropathology. Okay, this is from the Neuroscience Bulletin dated November 2023. Terahertz wave treatment effectively attenuated mitochondrial impairment, neuroinflammation, and neuronal loss in the brain. So it is suggested that terahertz waves may have the potential to be used as a novel therapeutic intervention for this devastating Alzheimer's disease. All right. So these are kind of neurodegenerative diseases. All right. So another application will be to communication technology. As you can see here, the communication satellite, right? So it's terahertz, terahertz, terahertz. And then this one, and as you can see, wait, I will go back here. This one, the picture on the right, that's one of the modern sources of terahertz that is already being used now in the communication technology, because terahertz is now tagged as the next frontier for the communication and electronic field. All right, because terahertz has a potential application in high-speed wireless communication systems due to its ability to carry large amount of data. So that's why terahertz is very, very useful in the communication technology. And aside from that, the greatest application of terahertz is in the broadband internet. So as you can see here, which is the average speed right now in our internet, kung medyo commercial yan, so that's 100 Mbps, right? But the usual thing sa ating mga cellphone is just 5 Mbps. Sa mga corporate, it's 50, ranging from 50 to 100 Mbps. But don't you know that it's just an average speed, right? So right now, the upgraded speed is now 1 GPS or equals to 1,000 times noong 100 Mbps, which is in other countries, they are utilizing now as this as a high-speed internet. But hold your breath. Why? Because meron pang mas mataas dyan. Ito na yung tinatawag natin na 1 Tbps, meaning to say 1 Terabps or 1 million times ng 100 Mbps. That's the most updated ultra high speed internet right now. All right, all those developed countries are already experiencing it now, especially the NASA. NASA is already using those ultra high speed for research and development. All right. So through these applications, we can now summarize the benefits that we can get from all those applications that we have mentioned. As you can see here, it is listed, the enhanced diagnostic capabilities, because early and accurate cancer detection is crucial for improving treatment outcomes and patient survival rates, right? And of course, we want to talk about safety, right? So this is particularly beneficial for vulnerable populations like children, mga pregnant women, patients undergoing frequent scan. Kasi hindi nga siya po pwede ng puro x-ray. So kailangan ng mga alternatives. And the best alternatives are terahertz devices. Okay, so terahertz devices is non-invasive. Again, meaning it doesn't require needles or incision. This translates to a more comfortable and stress-free experience for patients, especially those with existing medical conditions or anxiety. So again, it is painless and non-invasive procedures when you're going to use terahertz devices. And again, real-time monitoring. This is very, very important, right? Because by providing real-time data, terahertz technology could empower medical professionals to make more informed decisions about treatment. O operahan na ba nila or hindi pa? So that they can plan more for the patient's care. All right? And also, it's what we call the personalized medicine. Personalized medicine offers the potential for more effective and targeted treatments, leading to a better patient outcomes and improve the quality of life. So there's a lot of research papers on the different and numerous health benefits of the terahertz frequency. Name it. We have a lot here. All right. These are the journals, medical journals that we can read as reference for you to really inform that terahertz is really out there in the commercial and industrial usage and really helping a different industries. All right. So I will browse you to the latter part of this discussion about the future applications of terahertz in the next 10 years. All right. So it's gonna be benefiting the manufacturing industry in terms of the quality control. Very strict ang magiging monitoring when you are going to use terahertz in your manufacturing facilities. Okay, so what else? It can be also used to non-destructive evaluation. What do we mean by this? It is a kind of test used to inspect and evaluate materials and components or assemblies without causing damage. So this is a big help in the aeronautics, in the aerospace, automotive, jewelry, nuclear plant, all right, defense, oil and gas, and the electronics. Wow, it's really a big help to those industries. What else? It's also be beneficial to healthcare and diagnostic industry, right? It's gonna be a high level of preventive healthcare to all of us, right? So para again, madedetect yung mga tumors pa lang para hindi talaga siya mag-evolve into a full-blown cancers. And it's gonna be a high-end and high-tech hospital procedures. Looking at the doctor, how is going to operate a patient using terahertz camera, terahertz source there. Para lang siyang nag-game and watch. But it's gonna be very, very accurate. All right? So, wow, are you really amazed with the characteristic, with the application and the benefits of terahertz? That's why it is called as the wave of light by the American scientists, and also it was called as light of life by the Japanese scientists, and it was called as God's wavelength by the Chinese scientists. It's really terahertz technology. That's why it was tagged as the one of the top 10 technologies that will change the future world. And those terahertz technology is in our iTeraCare products, right? That's why it is called as the new revolutionary product in the health and wellness industry. All right, so you have now the idea about frequency, about the general information about terahertz, and that wonderful technology of terahertz is really the one there inside. It's one of the 3-in-1 core technology of our product. So as you have learned all those potential of the terahertz, it is there also in our iTeraCare devices. Those potentials are those in the very simple yet very powerful and very high-tech iTeraCare therapy devices. All right? So that ends the discussion about the
Darling.
frequency and about the terahertz. All right. So thank you very much for listening.